All right, so is this function odd or even? So from class, maybe you recall that what you do here is f of negative x, and you put that in for x. So you put negative x in for x, and then you say, oh, this is negative 1 over x. And if f of negative x equals f of x, the original, but with a negative in front, then it's odd.
Okay. So it's odd.
So this one's odd. But let me just really quickly, like if it was 1 over x squared, f of negative x is 1 over negative x squared, which is 1 over x squared. In this one, if f of negative x equals the original, then it's even.
Okay.
All right, so let's move on to number 2. All right, so vertical asymptotes of this one. So to find vertical asymptotes, first thing is that, is your exam gonna be multiple choice, or is that just the way this review is?
Um,
Do you have any
I
idea?
don't know. I've never taken one of her tests before.
Okay. Well, you'll know tomorrow, right? But if you have a friend, it would also be good to maybe ask. So the first thing you always need to do is factor.
Okay.
And I'll factor this real quick. But you wanna also be able to do this really quick as well. So when the factors cancel, that results in a hull, which is not a vertical asymptote.
Okay.
So those cancel. Whatever's left over, this is what's left over on the bottom. This becomes a horizontal asymptote. So like if the top was like x plus 4, then there would be, I'm sorry, vertical asymptotes. Vertical asymptotes. So if up top was like x plus 4, x minus 2, then these wouldn't cancel, and they would both be vertical asymptotes. But holes come first, holes and then vertical asymptotes. So the only vertical asymptote is when x plus 2 equals 0 or x equals negative 2.
Got it.
All right, number 3. To find an inverse, there is a recipe. And the recipe is fairly straightforward. You take y and f of x becomes y. That's your first step. Second thing is x becomes y and y becomes x. So wherever you see an x, you put a y. Wherever you see a y, you put an x. And then the third thing is you solve for y. So notice you subtract 5 from both sides. That's why I asked it's multiple choice, because you can get, some of these you can get rid of pretty quickly. And then to undo y cubed, you take the 1/3 power. So it's y cubed to the 1/3 power, x minus 5 to the 1/3 power. That undoes that. The left side just becomes x minus 5 to the 1/3 power. And you have your answer there.
Okay.
Five. So 5 is only really applicable if you're going to get a multiple choice type exam, because it says which of the following, and a which of the following question means that you have to actually look at the answers. So let's just look at a few of them. Like let's look at the black line to the dotted black line, and just try to focus on that stuff without everything else. So if f is the original, we'll call that the original, and this dotted black one is the new, well, yeah, the new. Tell me in words what's going on with it. Can you say like up, down, left, right, flip? What do you see?
Yeah, so it's right 2 units and then flipped over the x-axis.
Yes. Okay, that's very good. Now let me switch colors here. And and we'll go to blue. So we'll go blue to solid blue. Okay, and give me what you see there again.
That one is right 2-unit flipped over the x-axis.
So it's actually the same, right? It's
Oh,
kind of
yeah.
kind of interesting. Like it's flip x, and that's cool. That's the way that's what it's meant to be. So now how do we do that here? So rather than like let me just tell you what each of these does,
Mm-hmm.
and then you can see the order. So this one is right 2, then flip. This one is flip up 2. This one's a little bit harder. You actually have to factor this negative out. Okay, so see how the negative came out of both. So this is actually a flip y. The other ones were x. Maybe I'll put that in flip x. Flip
Mhm.
y. Well, actually, it's left 2, then flip y. So let me get that in there. Left 2, then flip y. This last one here is negative x minus 2 because you have to factor out the negative. And this one is right 2, flip y. So you can see that A is correct, but
Yeah.
that's not really what's important. What's important is like you learning like why each of these are the way they are, and maybe the last 2 are the most awkward or weird.
Mm-hmm.
Any questions on that or anything you want me to kind of clarify?
No, I'm good on that one.
Okay, my guess is you'll be asked to draw a graph with one of the transformations.
Okay.
Like it'll give you the solid triangle one and then say, like what is minus f of x minus 2, and you have to draw the new one. Do you get a formula sheet for this exam or cheat sheet or
We
whatever?
get a note card.
All right, so one thing you might put on your note card is the distance formula.
Oh yeah, I can never
x2
remember
minus
that.
x1 squared plus y2 minus y1 squared, and square root of that. So far, that's the only thing that I would put on there. Possibly like a transformation if you're not comfortable with these.
Mhm.
That might be good to put on there. Okay, so they're giving you points here. Like they're telling you like that's x1, y1, and that's x2, and that's y2. They do it sort of different. This is so bad. All right. Okay, I'll just show this here. So if you use this formula the way I've given it here, it's -1. I'm sorry. X2 is A. It's
Mhm.
A minus a -1 squared plus B minus 3 squared square rooted. And you might say, well, Matthew, that's not there. And you're right. You can also flip these so that A and B is x1 and y1, and then that's x2 and y2. When you do it that way, that's why it matters whether this is, because this is correct the way I have it here. It matters now because now it's -1 minus A squared plus 3 minus B squared square rooted. And you're like, oh yeah, that's C. These produce the same answer, but you have to kind of know that the one transforms into the other.
Mhm.
So in short, try to be short here, you want to know the distance from it. It looks like you'll have maybe a distance question on the
Okay.
exam. Okay, let's go to number 8. This is another which of the following. So instead of focusing on that, let's like look at the stuff going on the graph. So this right here, this vertical dash vertical line is a vertical asymptote x equals 1. This vertical, and then this horizontal asymptote is y equals 2. Okay.
Yeah.
And then it gets to like, well, I don't know what else you can say, like as x goes to infinity, y goes to 2. As x goes to negative infinity, y goes to 2. And then I guess we got to look at some of these here. So f has a vertical asymptote y equals 1. This is no, because it's x equals 1. It's not y equals 1.
Mhm.
Decreasing, this means that it's going, decreasing means it's going down and to the right. So see how it's going down and to the right?
Mhm.
Down and to the right. So you might think that's true, but it's not defined at x equals 1 because there's nothing going on there. So that one's not true.
Yeah.
F has a removable discontinuity at x equals 1. The only removable discontinuities are holes.
And there's no holes.
There's no holes. Does not include vertical asymptotes. So no, no, no. If you've ever taken any standardized test review, or if we've ever talked about it, be happy to do that with you in another lesson. D is whenever it says like a which of the following, you actually start backwards because they want you to go through the list and get to the one that is correct.
Mhm.
But it does have a horizontal asymptote at y equals 2.
Yeah.
Okay. Number 10. Number 10. This one, can you try on your own, please? Because I think you might be able to do this on your own.
Mhm.
It's just factoring, and just take a minute here. I'll check back with you in 30 seconds.
Okay. It's D.
All right, so you say it's D, is that right?
Uh-huh.
Excellent. Yeah, so you probably factored 3x out, and then you factored the trinomial that's there. Not too bad. Okay, 11 together. Sorry, I'm just looking ahead to see what's going on here.
Mhm.
We are good on time, so we'll just keep going here. Sorry. Down here, go up. Another which of the following, and again, that won't be on there, but so y equals natural log of x. You have to have some idea of what that looks like, and it looks like this. Are you allowed to use your graphing calculator on this?
No.
Okay, so you have to know that. There's like 10 parent functions you might need to know. Maybe it's
Uh-huh.
8. I don't know how many they have
I
now.
think you have like 12.
12, right? I don't know. Point is, you got to know what these things look like.
Yeah.
Roughly, because now it's going to say shrink, a vertical shrink by a factor of 1/3, then a vertical shift down at 2 units. Okay. Boy, that's tough.
I
So
just
it's,
don't know if it's A or C.
yeah, so it's 1/3 natural log x, and then it down 2 units. So one thing you could do is like set this equal to 0 to figure out where it crosses.
Oh.
And that'll give you a lot of help here. So it's basically where's the net, but this may not help you much. It's where's the natural log of x equal to 6. So yeah, it is A or C. Notice A has a point there,
Yeah.
and so does C. So there's actually enough to do. You actually can do this. This says the point 1, 2, -2, and this is the point 3, -2. So you just try them in your thing here. So 1/3 natural log of 1 minus 2. The natural log of 1 is always equal to 0. The log base b of any of 1 is always 0. This is 0 minus 2. So this one, that's why it's correct there.
Okay.
I'm guessing, again, you'd probably be given a graph and say, shrink it, move it, something like that.
Yeah. Instead of just asking which one is shrunk.
Yes. Yeah. Yeah. Again, 12 is kind of, your instructor says, try this one. I don't
What
know.
is it?
I don't know. Well, it's right. It's written on there. It's like, try this one. Try. Maybe it's your handwriting. I don't know.
No, it's not.
Okay. Okay.
You wrote that.
Okay. So this is a good one to kind of figure out, like, do you understand your parent functions? And you know, that's a lot to ask, but you know, the more math you take, the more that's like, oh, you're supposed to know this. So the parent function is probably easier to look over here to the right. Does sine or cosine start at 0 and go high? Do you recall?
I
So,
think it's sine.
so that's sine. So this is some sort of sine.
Okay.
Okay, and again, like if this is multiple choice, because 3 of them are sine, chances are it's probably a sine.
Yeah.
Okay. So you know that's fine. This one's harder. Like you have to know what this is. Now it's a curve. Okay, so it's not x plus 1.
Uh-huh.
And then we're to e to the x and natural log of minus x, which it could be either, truthfully. But let's see which one it is, because e to the x looks, you know, it goes this way.
Uh-huh.
But what is negative natural log of negative x do? So this is
We
where
make
it's
it
like,
positive, right?
so natural logs looks like this. So the negative x inside flips it
Mm-hmm.
like that, and then the negative there flips it again like that.
Oh, okay.
So it's not that one, but I mean it's close. Like it wouldn't, it's, you know, wouldn't be that hard to figure out. So that's the right.
Okay.
Again, like, are you gonna get one of these?
I don't think so, considering it says try this
Yeah,
and we have a test tomorrow.
right.
So
Well, you'll know more. I know more about this. So number 13 is a problem where, let me get this snipped in. The way you do this is you move the 7 over to the other side, and the order here is you always try to factor, then use quadratic formula. Now, do you remember the quadratic formula, or does that need to go on your note card?
negative b plus or something like that. Plus or
Yes.
minus the square root of
So all that, right?
something minus 4ac. Yeah, that.
Okay. If you can get that down, you know, you'll do it.
I should put that on there.
I was working with a student and they had the wrong formula down. So they got all the whatever it was wrong. And it was just one of those things where, like, if you, you know, if you're ever unsure, put it on a note card, equals 0. So this has two solutions, x equals 1, x equals minus 7.
Nice.
Hopefully they're all like that on there. All right, 14, yeah. Which of the following number lines shows the solution set for the inequality? So before we go to that, let's just write out what the solutions are to each of these just as practice. So for the first one, x is greater than or equal to negative 3.5. It's everything right of negative 3.5. B, x is greater than or equal to negative 2.5. So the brackets, you know, they correspond to greater than or equal to. They're all brackets. So this one would correspond to a less than or equal to. So for example, D is x less than or equal to 3.5. C is kind of weird. It's irrelevant here, but it says x less than or equal to 1 or x greater than or equal to 6/5. Okay, so to solve this, we're going to distribute the 3 to both. So it's 3x minus 3 plus 2 less than or equal to 5x plus 6. Okay, so go ahead and try solving that and let me know which one you get as your final answer there.
Okay. Okay, I got x is greater than or equal to negative 3.5.
All right, looks good. Okay. 15. Whenever I see an instructor star something, I guess I'm jumping ahead here a little bit, but is that the instructor's handwriting?
Mm-hmm.
Okay. All right. Well, so let's look at this. If f of 3 equals 7 and g is the inverse of f, okay, g equals f inverse of x, what is g of 7? So it's kind of like this. The answer is 3 because the only other number it could possibly be is that one there.
Mm-hmm.
So it's like saying like if 3 goes to 7, and this is f. It's just it backwards.
Yeah.
Okay. All right, let me do 16 and then move to the next section, and then we can come back if we have more time, but I like to try to break them up in half. If f of x equals 1 over x and g of x equals x squared plus 1, what is f of g of negative 5? So first, you have to find g of negative 5, which means to put negative 5 in for x. So you have to realize like, oh, I got to do that first and then that second.
Okay.
So negative 5, the quantity negative 5 squared is 25 plus 1 or 26. So you take the result of that, that is g of negative 5, and that becomes the input to f. So you're doing g of negative 5, but sorry, man, I got really bad there. You're finding you instead of g of negative 5, you're like, no, I don't need that anymore. I know what it is now. It's 26.
Oh, okay.
And so it's 1 over 26 because you put 26 in for x. So you take the output of g of x, and that becomes the input to f of x.
Okay. That makes sense.
All right. We're going to move to the other ones.
Okay.
All right, write the equation for the parabola with vertex at 1, 10 going through the point minus 1, 0. So whenever you're given the vertex, you want to use vertex form. Vertex form is y equals a x minus h squared plus k. So that's like a note card, probably. Think for that. H comma k is your vertex. So that's h and that's k. H is 1 and k is 10. Okay, so to find a, you need an x and a y. There's your x and your y. 0 equals a, negative 1 minus 1 squared plus 10. Now you're just solving for a. So you're going to subtract 10 from both sides. -1 minus 1 is -2. -2 squared is 4. -10 equals a times 4. Divide both sides by 4. And a equals -5/2. So that number goes back into this line here. And you're writing out your final answer. So it's -5/2, x minus 1 squared plus 10. Then you matched up to your answer, or you just be done there. You have to know vertex form.
Mhm.
Have to know that, and you have to know that that's your vertex.
Got it.
Okay. Number 2. So this is why, I mean, this is one of those questions where I ask like, can you graph it? Because if you graph it, you can answer these questions pretty quickly. If you can't graph it, it's really, really horrible.
Yeah, we can't use our calculator or Desmos.
Yeah, so you really, and you're doing this in person.
Mm-hmm.
Yeah. So like a table is the only other sort of option here for you. Unless you know what the graphs look like, which I wouldn't think you would know at this point. So let's do this. Let's do x, and then we'll do y equals x, y equals x squared, and y equals 1/x². So let's say it's 0. This is 0. This is 0. And this is undefined.
Mm-hmm.
So you might actually tell your instructor that like that's a bad question because you can't compare something that's undefined. Let's go to the other extreme. Let's say it's 1. 1, 1, and 1. So see how it's not helpful so far? You don't know anything in between.
Mm-hmm.
So let's try something in between, like 1/2, and then we'll see where we go. Well, this is 1/2. This one is 1/2 squared, so that's 1/4. This one is the flip of this one, so that's 4. So that tells us something. What does it tell you here? Which one out of these 3 is the biggest?
The last one.
And then this one's the next biggest, and then this is the smallest. So let's see if it holds for like 1/3, because that's smaller than 1/2. 1/3, 1/9, and 9 still holds. Okay, let's try it one more time. Let's try it for like 2/3. So that's 2/3. Now you got to square the top and the bottom, 4/9, and you got to flip that 9/4. So this again, it holds that 1/x² is greater than x greater than x² on this interval.
Okay.
If you were to graph this, you would see. That's why I kept asking, because you, and I'm sorry, be like, well, I can't graph, Matthew. Well, I know, but so there's y equals x, there's x². Okay, and then 1/x² looks like that.
Uh-huh.
So you can see how like visually it's easy. It's like, oh, of course that's the biggest, and then x, and then x². But if you don't know that, you don't know that. Now, if you switch the interval, like this 1/x² comes down here,
Yeah.
and then they actually all flip, like x² becomes the biggest, then x, then 1/x². So it's, it's really interesting to see what happens there. All right. Determine the asymptotes of, all right, so we're up to number 3. Wait, did I skip one?
Yeah, that's 4.
All right, let's we'll do 4 and then we'll come back. Determine the asymptotes of. So again, you want to factor the bottom, but you can't factor
Mhm.
the bottom, but it's not possible. So there's no vertical asymptotes,
Okay.
no VAs, because there's no place that it equals 0. Like if you said x² plus 1 equal to 0, that just doesn't happen. There's no place where that's true. Horizontal asymptotes. The degree of the numerator, do you know what that is, or do you recall that?
It's the exponent.
Yep, it's the exponent. It's 1. The denominator is 2. 1 is less than 2. So whenever the top is less than the bottom, it always goes to y equals 0.
Okay.
So this is not correct. Maybe I didn't. That's weird. Yeah, so the answer is C, and they have an error in the this is an error, by the way. You can also tell your
Yeah,
instructor about that.
it's y equals 0, not x equals 0.
Right. So maybe get some credit for that. The other case is what if these degrees are the same? So like what if it was x squared plus 3 over x squared plus 1? What would the y equal be? And actually, let me put a 2 and a 5 there to make it more clear.
2/5.
Yeah, it's the ratio of those when these are the same.
Okay.
All right. And then the stuff we talked about last time, and I believe we were doing that, was polynomial division.
Mm-hmm.
That's the case, and maybe we'll get one. Oh, we get that in 5, so we'll come back to that. All right, number 3.
Yeah.
Number 3. All right, find a cubic function with zeros at 2, 3, and 0. All right, so normally you would have to actually do this, work this out, but it's always x minus the 0 times x minus the 0 times x minus the 0, and so on. Like if it was a 4th degree, it would just keep going. So yours is x minus 2, x minus 3, x minus 0. Now, because the answers are here, we're going to move that out in front so you can see how they have it, but it's x minus 2, x minus 3. The truth is, though, there's really an a here and an a here and an a here. So there, it's kind of implied like that a equals 1 for this one, but looks like that's the right answer. And then sometimes they want you to multiply these out. They want you to FOIL and then multiply by x. Yours is not asking for that, but just be aware that that could be could be the case.
Okay.
Okay, 5.
Mm-hmm.
5. All right, so there's this thing called the remainder theorem. Maybe you saw that in class.
Yeah.
And the remainder theorem is like basically says like whatever the remainder is, that's what the output is when you put that number in to the function. So if you had a calculator and you just put that number in, you would get the that's the output. But since you don't have a calculator, you use synthetic division. So the -2 goes in the box, and then you put the coefficients there: 2, -7, -8, 14, and 8. And let's say like this wasn't here, 14x, you would put a 0 there for it.
Yeah, I
Okay.
remember that.
All right, so now bring this number down. You always bring that first number down, 2. Then you multiply, -4. Then you add. So there's really a 0 here. That's why you bring it down, because it's 2 plus 0. This is -11. -11 times -2 is 22. +14. 14 times -2 is -28. -14. Multiply again. 28. 36. Always double check your multiplication and your adding, because if you make a mistake, it propagates through the whole problem.
Yeah.
So it's worth a check again. So the remainder here is 36. What that means is f of -2 is 36. So if we were graphing this thing here at -2, there's a value up here at -36, or at 36. There's a point there at -2, 36. That's what it's telling you.
And then the graph like doesn't touch it, or
We don't know. We don't know.
oh.
So then this thing gets into patterning, which I mean, I actually haven't seen this in a while. Your answer space talks about the following. It says even pattern. Oops, let me do that. So it says that -2 is an upper bound for the real zeros if there's an even pattern. And then it's a lower bound if it's an alternating pattern. So I would tend to say that this is an alternating pattern.
Mm-hmm.
And so I would believe that B is correct. Was this emphasized in class?
No, I've
Okay.
really never seen this before.
All right. What you have to be able to do for sure is do a polynomial, or sorry, synthetic division problem like this.
Yeah, I know how to do the synthetic division, but I'm like the alternating path. I guess it's self-explanatory, but
So what, based on this, if we were to put in if we were to do -3, we should get a number down here, because it's bounded between those two, like it must cross somewhere between them.
oh,
But that's,
okay.
I mean, this is actually really, like, this is a really good question for like interpreting this stuff, but I don't think you need to know all that.
Yeah, I mean, all it said was there's going to be a really small question on synthetic division, so I'm not concerned about what it all means.
Okay. Number 6 says find all the roots and their multiplicities for this function. So you always try factoring first. Factoring is great. Love factoring, do it all the time because it's like you got to do it right away. You could factor out an x squared minus 10x plus 23. So this means, and you set each of these equal to 0, you set x squared equals 0. That means x equals 0 is a root with multiplicity 2 because of that exponent right there. That 2 exponent tells you the multiplicity. Okay, so we're down to B or C. Okay, and you can right away tell the answer is D because there's got to be other roots here. They get those through quadratic formula. And I don't think we should spend the time doing that. So we can get through some more stuff here. Inside, inscribed. Okay. And you're not allowed to use calculators, is that right?
Correct.
I keep asking because like 8 is a calculator problem. So we'll,
It is.
yes, but we're gonna do 7 first.
Okay.
A square of side length S is inscribed in a circle. So here's your favorite circle. There's a square, really bad square, but the square has side length S, 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 great. Write the area of a circle as a function of S. So you know the area of a circle is pi r squared, and there's r, but we don't have any r's, we have s's. So we need to figure out how to relate r and s. So if you keep going down here, that's another r. The triangle is a right triangle because it's a square. So you have a triangle down here, S, S, and 2r. And the relationship is s squared plus s squared equals 2r squared by the Pythagorean theorem. Is that something that you remember?
Yeah, but I don't like it.
Yeah,
This seems like way too much geometry.
it is. It's a lot here. Because the other question they could ask that if your instructor just changes them is he could build a square and put a circle inside of it. But we're not doing that problem. So we'll just keep going on this. So this is 2s squared because you add them together, 4r squared. We want r squared. So this is one of those this is actually a really good SAT HT thing because you don't want to solve for r, you want to solve for r squared.
Oh, okay.
And you divide by 4, divide by 4. It's a small shortcut, but it's major when it comes to like saving time. So r squared is really 1/2 s squared. So that goes back in here. So area of your circle is pi 1/2 s squared. So it's pi over 2 s squared.
Okay.
All right, any follow-up on that? I know you didn't like that, but
Oh no, it's okay. I know how to do it. It's just not my favorite.
no. All right, so we're gonna do number 8 without a calculator. We're just gonna like show how to do the average rate of change, because that's a formula you might need to know. So
What is that?
so the average rate of change, or AROC, as the instructors like to call it, is f of b minus f of a over b minus a. And you might be wondering, well, what is a and what is b? Well, that's a and that's b. A is always the smaller one, smaller. Okay, so you have to find f of -1, and you do that by putting -1 into this thing here. So this is e to the -1 minus 1. That's e to the -2, or you can write it as 1 over e squared. Then you need f of 4. So that's e to the 4 minus 1, e cubed. Okay, and now it's just putting these things back in. So f of 4, well, let me put these numbers. So it's f of 4 minus f of -1 over 4 minus -1. And we have these. F of 4 is this e cubed. This f of 4 is e cubed minus f of -1 is 1 over e squared, all over 5.
Okay.
All right, we've got 6 minutes left. I would like you to spend 1 minute looking through this rest of these and picking out the ones you want us to go through. Just spend a few seconds in each one.
Okay.
See if you can figure out where to go next.
Let's do 15.
All right, let's do it. Which of the following are solutions to the equation? So let me, again, like your exam will probably just say to solve,
Yeah.
I guess. I don't know why instructors do this, but they do. So to solve this, you have to first realize that you have to restrict the domain. And you basically set the bottom equal to 0, and x cannot equal -2, because when you put -2, you're dividing by 0.
Yeah.
So you do that first, and now because of that, we already know that that's out and that's out.
Oh.
But that doesn't help us that much, because if 4 works, that's great. Well, actually it does help us. If 4 works, we actually just try it. But that's not how you do this to solve it. That's just like the multiple choice part of it. To do it correctly, to just quote solve it, you have to make a common denominator. So your common denominator here is x plus 2. So it's x times x plus 2 over 1 times x plus 2. And then let me snip. Actually, I'll just keep writing here. 4x over x plus 2 equals 8 over x plus 2. Now, because all the bottoms are the same, you can just deal with the top.
Oh, yeah.
So it's x times x plus 2 minus 4x equals 8. X squared plus 2x minus 4x equals 8. X squared minus 2x, bring the 8 over. You always factor first, x minus 4. X plus 2 equals 0. You can do all this. I'm just rushing through it. So you get 2 answers and you're like really happy. But if you don't do that analysis that we did earlier, you will choose the wrong answer, because
Oh, it's not.
right.
It can't be -2.
Right. And then you're not happy because you got the wrong answer. So keep that in mind. I wish you knew. I'm sorry we didn't do the lesson earlier, because I mean this would have been a great thing to ask your instructor, but because we would tackle a lot of these problems differently. We would look at the answers first. So I'm sure we've got time for one more question at least. So go ahead and look through again and just see where you want to go for for here to
Okay.
work through this.
Let's do 13.
This is like, yeah, this is like a standardized test question.
Are these all like
A lot of
I
them are.
think she must have just got them from like a book or something.
Yeah, very, very likely.
Oh wait, it literally says standardized test prep questions at the top.
Yeah. I don't know what to tell you.
That's so funny.
All right, so this is talking about this has a roots and a multiplicity. So the first root is when x minus a cubed is equal to 0, and it's when x equals a. So there's a root at x equals a. What is its multiplicity?
3.
It's 3. Since it's odd, we know that it crosses. The next root is at negative b, because negative b plus b is 0. It has a multiplicity of 2. That's even, so it touches. And a touch is like that, or like that.
Uh-huh.
And then finally, there's a root at c. It's also got multiplicity 2, and it's even, so it touches. So in short, I'm trying to say that if it's odd, it crosses. Like if it was to the power of 1, it's odd, it crosses. If it's even, it touches. Then you can go back and like try to answer some of these. So f has a root at minus b. That's true. Okay, that's not the answer, because that's for the ones not true. Not true. Again, that's standardized prep stuff. So if it's true, if you're looking for the true, there's 1 true and 3 false. This one has 3 true and 1 false. So you don't pay attention to that word. That's why this is standardized prep. You end up like choosing A because you're like, oh, I found the one that's true. I'm done. Okay. The graph of f crosses the x-axis at C. Is that true? It touches at C.
No, it touches.
Right. X equals C is a 0 of multiplicity 2. That's true. And then this one's also true without trying to explain why.
Okay.
All right. So maybe the thing to take away from this is that if your exam isn't anything like this standardized test prep, for next time to ask your instructor, like, could you give me something that's more related, or, we could look at it differently.
Yeah, I'm not sure why this was posted as midterm review, but I think I feel more prepared for the SAT.
Yes, you should be. Okay. That gets us to the end of our lesson. Thanks so much for letting me reschedule with you last night, a personal matter to deal with. And
Yeah, no worries.
I'm glad to be helping. So thanks for scheduling, and I'll see you next time.
Yeah. All right. Thanks, Matt. Bye-bye.
Great night. Bye now.